Hello students, in this lecture we see the remaining examples of the exercise 4.2. Okay, here solve the following equation. Here it is a given determinant and the value of determinant it is a 0. We want to solve this equation, that means we want to find the value of the x. Okay, here we can directly expand this determinant, that means find the value of this determinant x plus 2, and then in the multiple of x plus 2 we take the determinant of this term. Okay, here by expanding it is a lengthy method. Okay, here by using the property we simplify first this determinant. Okay, by using the property of determinant. Okay, and then we expand this determinant and solve it. Okay, here see carefully, it is an example. Okay, solution here it is a given. Okay, here it is a given equation. Now first here we perform, it is a R2. Okay, R2 minus R1, see carefully, R2 minus R1, R2 minus R1. Then here the x in this row 2 is a deleting, and when we take R3 minus R1, again the x, that is the variable in row 3, is also deleting, and if the variables are the absent then we easily calculate. Okay, now here first R2, it is R2 minus R1, then the determinant it is, see carefully. Okay, here first row as it is x plus 2, x plus 6, and it is x minus 1. Here transformation is, it is R2 minus R1, R2 minus R1, that means x plus 6 minus it is x plus 2. Okay, therefore x and minus x get cancelled and it is a 6 minus 2, it is a 4. See carefully, here transformation it is R2 minus R1, R2 minus R1, that means row 2 minus row 1. Okay, the subtraction of the corresponding elements of the row 2 and row 1. Okay, here x plus 6 minus x plus 2, it is a 4. X minus 1 minus x plus 6, x get cancelled, it is a minus 1 and it is minus 6, we get here minus 7. Here x plus 2 minus x plus x minus 1, so here x get cancelled and it is a 2 minus minus 1, it is a 3. Okay, here it is a row 2. Okay, here we can take the calculation row 2 with row 1, and we take the calculation of row 3 again with row 1. Okay, R3 minus R1, here R3 minus R1, x minus 1 minus x minus 2, see carefully, x get cancelled, it is minus 1 and minus 2, we get here 3. Okay, then x plus 2 minus x plus 6, R3 minus R1, R3 minus R1, x get cancelled, 2 minus 6, it is a minus 4, and here x plus 6 minus x minus 1, x get cancelled, 6 minus minus 1, that is the 6 plus 1, it is a 7, and then it is 0. Here it is a original determinant. By using the property of the determinant we get this determinant, and here it is easy to expand for this example. Okay, here it is original. Okay, it is a lengthy procedure. Okay, but here it is easy to expand other than this. Okay, now we expand this to find the value of this determinant. See carefully, here first x plus 2 into, delete the row and column of this determinant. Okay, and find the value of this determinant. It is a minus 49 plus 12, see carefully, minus 29 minus, okay, the product of this, and here product of this it is minus 12, so here it is a plus, then minus x plus 6 into, okay, change the sign of the middle term, into here it is 28 plus 9, 28 and it is plus 9, and plus x minus 1 into minus 16, and here it is a minus 21, minus 16 minus the product of these two term, and product of these two term it is a plus 21, so minus as it is, and it is a 21 and is equal to 0. Okay, here it is a expansion of the determinant. First we use the property and then expand it. Now the calculation is x plus 2 into here minus 49 plus 12, it is a minus 37. Okay, then minus x plus 6 into, it is 28 and plus 9. 28 plus 9, again it is a 37. See carefully. Okay, it is 37. And here plus x minus 1 minus, it is minus 37. Okay, here now we multiply minus 37 by this, minus 37, it is this, and 37. Okay, it is simple to common the 37. Okay, here we can take common the minus 37. Okay, therefore minus 37 we will take common, then here remaining x plus 2, here it is minus 37 common, but here plus 37, so it is a plus x plus 6, and here plus x minus 1 is equal to 0. Now this minus 37 will be, take the RHS, and it is a 0, and here it is x 3x. Okay, 37, here it is the multiple, then we remove it is in for the RHS, and it is a 0 upon minus 37, it is a 0. Okay, now x, it is a 3x, and here 2 plus 6, 8, and it is minus 1, it is a minus, 2 plus 6, 8, it is a plus 7. Plus 7 is equal to 0. 2 plus 6, 8, and it is minus 1, it is a plus 7, and therefore x is equal to 7, it is a minus and upon 3. The value of x, it is a minus 7 by 3. Here we use the first property, that is the transformation, and then we expand this determinant. Okay, now we will find the value of the second example. Next example, solve the equation. Second example, x minus 1, x minus 2, 0, x minus 2, x minus 3, 0, 0, it is x minus 3 is equal to 0. Now you can solve this determinant first. Okay, again here there are the variables x minus 1, x minus 2, x minus 3, but here see carefully, these three elements are the 0, and here these three elements are below the diagonal. Okay, here it is a diagonal, and all elements below the diagonal are 0, then the value of determinant is the product of elements in the diagonal. Okay, it is a property of determinant. Okay, if the all elements are below the diagonal or above the diagonal are 0, then the value of the determinant is product of the elements of the diagonal. Okay, now here it is a second example, it is a question. Now for the solution, it is given that, okay, here it is given, here all elements below the diagonal are 0. Okay, therefore the value of the determinant, it is x minus 1, x minus 2, and it is x minus 3 is equal to 0. Okay, here value of this determinant, it is a product of the elements in the diagonal. Okay, it is our properties of the determinant. Okay, I think it is the 7th property, okay, in our textbook. Okay, here now it is a relation and it is equal to 0, and therefore it is obviously x minus 1 equal to 0 or x minus 2 equal to 0 or x minus 3 equal to 0, and therefore x equal to 1 or x equal to 2 or x equal to 3. Okay, here it is the solution for this example. Okay, see carefully, it is a two-step example. Here all elements below the diagonal are 0, therefore the value of the determinant, it is the product of all elements in the diagonal. It is. Okay. Now next example, it is example number 6 in the exercise 4.2. If four plus x, 4 minus x and 4 minus x, it is a 4 minus x, 4 plus x and 4 minus x, 4 minus x, 4 minus x, and it is 4 plus x is equal to 0. Then find the value of x. Okay, it is the same example as our first example in this lecture. Here again, here all elements are, it is in the form of 4x plus 1 or 4, it is 4 minus x or 4 plus x. Okay, if we find directly expanding the value of the determinant, there it is a 4 plus x into the value of this determinant. It is a lengthy procedure. So first they cancel the variables by using the property, okay, addition of the row or the subtraction of the row. Okay, here given it is, see carefully, 4 plus x, 4 minus x, it is 4 minus x. Then 4 minus x, 4 plus x, and it is 4 minus x. 4 minus x, 4 minus x, and it is 4 plus x is equal to 0. Okay, now here it is a 4 minus x, 4 plus x, and it is a 4 minus x. Okay, there are the two terms, that is the 4 minus x or 4 plus x. Okay, to simplify, we cancel the 4 and all x. Okay, when we subtract this, 4 get cancelled. Okay, here see carefully, here we take the transformation, it is a r2 minus r1 and it is r3 minus r1. See carefully, first we take the transformation r2. Okay, here r2 minus r1, see carefully. Okay, here r1 as it is, that is a 4 plus x, 4 minus x, and it is 4 minus x. Okay, here first transformation, it is r2 minus r1, r2 minus r1, r2 minus r1. So 4 minus 4 get cancelled, but here minus x and it is minus x, it will be minus 2x. Here 4 get cancelled, but it is again minus, it is plus x minus minus x, we get here 2x, and here again 4 get cancelled, and it is x also get cancelled, 0. Now see carefully, in this row 2 there is a 2x, and it is a 0, so we take the 2x common. Okay, but first before that we take the again transformation for the r3 here, and it is a r3 minus r1. Okay, we can both the transformation of the r2 and r3 about the r1. Okay, now again r3 minus r1, 4 get cancelled, it is minus x, again it is a minus 2x. It is a 4 minus x, both are cancelled, and it is a 4 plus x minus 4 minus x, it is a 0, and it is a 2x is equal to 0. See carefully. Okay, now from row 2 and from row 3 we can common 2x. Okay, here 2x from row 2 and 2x from row 3. Okay, 2x we get common from row 2 and 2x get common from row 3. Then the determinant is, it is 4 minus x. 4 plus x. 4 minus x, and it is 4 minus x. Now we can take common 2x. So here it is a minus 1, 1, and it is a 0. Minus 1, 1 and 0. We take 2x common. And from row 3 also we take common 2x. So again here minus 1, 0, and it is 1. And the value of determinant, it is 0. Now we expand the value of this determinant. Okay, here because the row 2 and row 3 are the numbers. Okay, and easy numbers. Okay, here we expand this determinant, but this 2x into 2x is a multiple of determinant. So we can write first it is a 4x square. 4x square into, we take the determinant, it is 4 plus x. 4 plus x into, okay, to find the value of this determinant, 4 plus x into, delete the row and column of 4 plus x and obtain the determinant, this 1 0 0 1, and the value of this determinant, it is a 1 minus 0. We can write it is a 1 minus 0. Then change the sign of the middle term, it is a minus 4 minus x and into, here eliminate row and column, we get minus 1 0, minus 1 1, therefore minus 1 plus 0, minus 1 plus 0, and last plus 4 minus x into, it is a 4 minus x into, delete column and row. Okay, obtain the determinant, is the 0 plus 1, 0 plus 1. Okay, and now is equal to 0, and therefore 4x square, see carefully, it is a 1 into 4 plus x, it is a 4 plus x. Here it is a minus 1, see carefully, it is a minus 1 and this minus, it is a plus, so it is a plus 4 minus x, plus 4 minus x, and here it is a 1 into this, plus 4 minus x, is equal to 0. Therefore 4x square into, here it is a 4 plus 4 plus 4, it is a 12, x minus x, and it is a minus x, is equal to 0, and therefore 4x square is equal to 0, or 12 minus x is equal to 0, and it is a 4x square. Okay, x square equal to 0, and therefore x is equal to 0, or x is equal to 12. It is the last answer of this. Here we use the transformation and then directly, and then again we use the property of the determinant, that is the, we can take the common element from row 2 and row 3. The common, it is a 2x. Okay, now we take the last example in this exercise. Now the last example, that is a question number 7. Without expanding determinants, show that determinant of 1 3 6 6 1 4 and 3 7, 12 plus 4 into 2, 3, 3, 2, 1, 2, 1, 7, 6 is equal to 10 into determinant of 1, 2, 1, 3, 1, 7 and 3, 2, 6. Okay, here without expanding the value of determinant we can show this. Okay, now here it is a LHS. It is the first determinant 1, 3, 6, 6, 1, 4, 3, 7, 12 plus 4 into 2, 3, 3, 2, 1, 2, 1, 7, 6. Okay, here without expanding determinant, that means here we use the properties of the determinant. Okay, properties of determinant. Okay, so see the first determinant, we can take the common in the first row, second row and third row. Okay, we cannot take common any number, but here in the third column, okay, we can take common the element 2. Okay, here see carefully, it is a 2 into here first column as it is 1, 6, 3, second column as it is 3, 1, 7, 1, 6, 3, 3, 1, 7 as it is, but in the third column we take common 2, so here it is a 3, 2 and it is a 6, 3, 2 and it is 6 when we take common 2, and then the second determinant as it is 2, 3, 3, 2, 1, 2, 1, 7, 6. Okay, here see carefully, here we will common 2 from the third column. Okay, see carefully, we common the element third column. Okay, element 2 from all elements in the third column, it is a 2, 6, 4, 12 when we common 2, it is a 3, 2 and 6, 3, 2 and 6. Okay, now it is a property of the determinant. Okay, now here the observe that now these two determinants, there are the column 2, column 3, column 2 and column 3 are the same. Column 2 and column 3 are the same in both the determinant, only the column 1 is different. Okay, here the column 1 is different, we can take the common element from the column 3, we multiply the column 1, column 2 and 3, column 2 and 3 are the same, only the column first is different, so we can write this, see carefully, it is a 2, 12 and 6, we multiply by these two, 2, 12 and 6, okay, 3, 1 and 7, 3, 2 and 6 as it is. Here again the column 2 and 3 are the same, okay, first and second determinant, so we multiply this, it is 8, 8 and 4, we multiply the first column, therefore it is 3, 1 and 7, 3, 2 and 6. Okay, here see carefully, in both the determinant there will be addition. Okay, and the second column and third column are the same. Okay, second column and third column are the same, and here we know the property of the determinant, we can express the all element in the row or column as the sum of the two numbers. Okay, here we can express the all elements in the row or column in the sum of the two numbers, then the value of determinant is same as the obtained two determinant. Okay, sum of the two determinants. Okay, and here it is a sum already given, but here column 2 and column 3 are the same, so we can express the sum of the all elements in the column first. Okay, here this determinant can be written here, see carefully, it is 2 plus 8, column 1, 12 plus 8, and it is a 6 plus 4. Okay, here we can adding the column 1. And here second and third as it is 2 1 7 3 2 6. Okay, here. And now this can be written as it is 10 3 3 21 2 10 7 and 6. Okay, see carefully this. Okay, here we can use the property when we express the all elements in the column or row as the sum of the two numbers, then the value of the determinant is the sum of the obtained determinants. Here suppose it is the original determinant, we can express this in the column first elements in the sum of the two numbers, then we obtain this determinant. Here we use this property in the reverse order. Okay, here. Okay, and now we can take 10 common from the first column. It is 1 2 and 1 3 1 and 7. It is a 3 2 and 6. Okay, see carefully. Okay, here common 10. Okay, from C1. Okay, and now this 10 and this determinant will be RHS. Okay, see carefully. 1 3 3 1 3. Okay, here one more step. Here it is a 1 3 3. It is a row, but in this our RHS 1 3 3. It is the first column. So we interchange all elements. Again we use the first property. If we interchange the all elements in the determinant, if we interchange all rows and columns in the determinant, then the value of determinant remains unchanged. So we interchange the row and columns. Here 10 as it is, row becomes column and column becomes row. It is 1 3 3. It is a row. Second row. Okay, we can write second column 2 1 2. It is 1 7 6. See carefully. Okay, 1 2 1 3 1 7 and 2 1 6. Okay, and it is RHS. Okay, here we use again property, that is the first property. We interchange the row and column, then the value of determinant remains unchanged. Here row becomes columns and columns becomes row. Okay, here we use the properties. See carefully. First common 2 from the column 3, then we multiply the column 1 of both the determinant. Here we multiply by 2 and here we multiply by 4. Okay, why? Because column 2 and column 3 are the same, only the column 1 are the different. Then here it is addition is given. So here these are the two determinants are in the form of the sum of the two determinants. Then again we use the property. Okay, here. Okay, see carefully this.